section, we're going to study adding and subtracting of algebraic expressions. Particularly, we are going to understand what a term is, what some factors of a term are, the coefficient of a term, and then we're going to talk about monomials, binomials, trinomials, and many nomials. We're then going to find like terms, and we are going to add and subtract those like terms, ultimately finishing by simplifying algebraic expressions that have grouping symbols, powers, etc. So first of all, let's talk about the terms of an expression. This first problem number 1, has 2 terms in this expression. Let me go to the next one. This next one has 4 terms. And then finally, the last one has 2 terms. I'm going to go back and identify those. So in the first one, a 7x is a term. A term is a group of factors, so 7 times x is a term. Terms in an expression are separated by plus and minus signs. So the next term is this y term, but it does have a -1 in front of it. So we would say that the 2 terms in this expression are 7x, that's the first one, separated by a plus and minus sign, this minus sign. The y term is called a -y because whenever you subtract y, you add a -y. The 4 terms in this next problem would be the letter x. Remember, it's a group of factors, so you can think of x as 1 times x. The number 4, you can think of it as 4 times 1 if you wanted. 7y. And finally, remember that when a term has a minus sign in front of it, it's the same thing as plus a -2z. So I would call that term a -2z. So there's the 4 terms. Finally, a term can be a fraction, x over 2. And then finally, the last term here is 3. Next, let's find the coefficients of each term. And the coefficient of a term is just the numerical value in front. So I'm going to highlight. So for example, the coefficient of this 6x squared is the number 6. Remember, this minus sign right here, it's the same thing as plus a negative, and it happens to be a -1. So the coefficient for this one is just that -1 right there. We even call the 3 a coefficient. While it is a constant, 3 can also be thought of as 3 times x to the 0 power, because x to the 0 power is 1. So we can think of that as a coefficient of 3. So this coefficient is 6, this coefficient is a -1, and this coefficient is 3. In number 5, there's a 1 in front of the y. And so the number that is in front of the y, or the coefficient, is 1/4. So there's the coefficient. In the second term, the coefficient is a -7. In the next problem, the coefficient is 7.4 for the x squared term. It's 0.3 for the x term, and 5 for the constant term. All done. Now, let's identify like terms. So terms are like terms if they have the same variable, a, and they're raised to the same power. So if that a had an exponent, they'd have to be raised to the same power. But nonetheless, those are 8 apples and then 4 apples. When we get down to the next section, what we're going to do is we're going to combine those and call those 12 apples. So you can combine like terms. Those are the only like terms in that problem. If I was trying to simplify this expression, then I would still want to put the -3b and the -7z at the end. These are not like terms because this is brownies and this is zebras. And you can't combine brownies and zebras. You can only combine like terms. So the 8 apples and the 4 apples, you can call 12 apples. You don't do anything with the a, you're just adding the coefficient. Again, my goal here was just to identify the like terms, so I'm just going to do that now. I'm not going to simplify these expressions. So this 5x squared and the -9x squared are like terms because they both have an x and they're raised to the second power. That's why they're like terms. the minus 3x and the positive 7x are like terms. They're both xylophones. X is raised to the first power. They can be combined later on. And then finally, the minus 2 and the positive 12 are like terms. They're just numbers. Let's go back and let's look at number 9. So we got to be careful here in number 9. So let's see. I'm looking for x's and y's, and they have to be the exact same power. So, yikes. I'm thinking that I see this, xy squared and xy squared. Those are called like terms because their variables are the same and the exponent on any one variable is the same. None of the rest of these are like terms. The first term has an x squared and a y cubed. Neither of these have an x squared and a y cubed. This has an x squared, but it doesn't have a y cubed. So likewise, neither do, I was trying to erase there, neither do the next two terms. So if I was trying to combine my like terms, in this one, I would only add this 3xy squared and the 5xy squared to be 8xy squared. Again, at this moment, that is not my goal, to combine like terms. Now I am going to move on to simplifying expressions, and this is called the distributive property in algebra. And that is that I want to take the number 6 and I want to multiply it both by the letter x and I want to multiply it by essentially a negative 1 because this is plus a negative 1. I don't tend to worry about writing that plus a negative 1 at all. When I do, let me get my pencil back. When I distribute this, the 6 times x is just 6x, and the 6 times the minus 1 is a minus 6. So my answer is 6x minus 6. I'm going to write it a little bit more cleanly. 6x minus 6. So here I'm taking a negative number and multiplying it by a positive letter. So that will give me a negative 3 times y when I multiply those together. This is a negative 3 times a positive 5. Remember, a negative 3 times a positive 5 is a negative 15, and I can write that either as minus 15 or I could write it as plus a negative 15. I'm going to write that here. That is not my habit. I do not tend to write that as plus a negative 15 when it's reading. I'm going to erase this. When it's minus 15, I don't tend to write it as plus a negative 15. Okay, so let's distribute. And periodically you should pause and do the next few problems yourself. So this would be one that you might do yourself. But so pause right now if you want to do that. I'm going to go ahead and finish it now. 4 times 2 is 8, and I just tag that x squared along. 4 times that minus 3 is a minus 12. And 4 times a minus 8, 4 times 8 is 32. 4 times a negative is that negative. Or when this number 4 is positive, these signs just come down. I'm all done distributing. Please don't try to combine these because this is x squared and this is just an x term and this is just a constant. They cannot be combined. Let's turn the page. Alright, so next I want to find the opposite of a binomial or a trinomial, and essentially, so I'm asking you to find an opposite, but I want you to know, I gotta watch my screen spacing. I want you to know that that's like taking a negative 1 here. A lot of people think of it as taking a negative 1 and multiplying it times what's in the parentheses. So a negative 1 times 3 is a minus 3x. A negative 1 times 5 is a minus 5. So essentially the signs got changed. So when you take this negative and multiply it by this term, it becomes a minus 2y squared. And when you take this negative and multiply it by that negative, it becomes a positive 7y. And then finally this negative times a positive 13 gives you a minus 13. Before I close this section out because I don't want you to have to hear too much at any one time. Let's go ahead and simplify a few expressions on this page. So what we're trying to do is we're trying to combine like terms. So first of all, I've got a 7x and a 3x. Those are like terms. So they combine. I'm taking the 7 plus 3. That combines to be 10. So what I have there for is a 10x, and I'll just bring that minus 1 down. So again, you're just trying to combine your like terms. So 6a, and then you need to take away a 1a. So that minus sign with nothing there means there's a minus 1 of those apples. So 6 apples, take away 1 apple is 5 apples. And then finally, a negative 4 and a positive 2. The 4 overpowers the 2. I'm adding those two numbers together. Their difference is 2, and the 4 has a negative sign. So I'll have a negative 4 plus 2 is a minus 2. All right. You should go ahead and try the next for yourselves. And then, so hit pause, and then come back to me and see what I get. Okay, 8x and 13x. Those are like terms. They combine to be 21 of those. A minus 2y and a positive 14y. A negative 2 and a positive 14 add to be 12y. Only the a squared terms are like terms. 4 minus 3 is 1a squared. You do not need to write that 1. You do need to bring the minus 9a down. Next, I'm going to look at, let's see, I've got a couple more problems here. Let's take sometimes we would put these in alphabetical order. I'm kind of looking to see what I might do here. But y would be first in terms of alphabetical order. So 9y, and then let's take away 6y, leaves us with 3y. This is a 1z and a 5z for a total of 6z. And then finally, I've got this negative 15 and this negative 3. They're like terms. They combine to be a negative 18. Let's see, on this last one, I think it's the a squared b that are like terms. So 3 take away 7. So that's what you're doing here. You're going 3 take away 7 is a negative 4. So the coefficient for the a squared b term will be a negative 4a squared b, and then bring down your 5ab squared. Next, let's collect our x terms. And so those coefficients, those decimal values, add to be, looks like 4.9x. Here I have a minus 1y, and then a minus 0.5, or minus half. So it looks like I have a minus 1.5y. All right, to conclude this page, and we'll pause to take a break. Like terms are terms that have the same variables, and the variables of each of these terms must have the same exponent or power. If there is no coefficient in front of a variable, such as this z right here, if there is no coefficient in front of the variable, the coefficient is assumed to be the number 1. Okay, let's pause. Let's take a break.